Hi everyone and welcome. In this video we will see unidirectional Modbus TCP IP to MQTT publisher using JavaScript for single Modbus TCP device. So your JavaScript will act as a Modbus TCP IP client which will connect to your Modbus TCP IP device or TCP IP server, and it will read the data. And then after, JavaScript will act as a MQTT publisher and it will publish your Modbus TCP data to MQTT broker. It can be your local host MQTT broker or it can be your cloud MQTT broker. Okay, and this code is only working with the single Modbus TCP device. You can modify the index.js file along with the config.json file to make it work with the multiple Modbus TCP device, but I will modify the code and we will cover that code with the working procedure in the separate video. Okay, now this video is mainly focusing on single Modbus TCP device. So JavaScript will read the data and it will publish to MQTT broker. Now if you want to get the code, then you can click here and you can get the code. Okay, now let me show you the data flow diagram. So here is the data flow diagram. So your JavaScript will connect to Modbus TCP IP device. Okay, and JavaScript will act as a Modbus TCP IP client in order to connect with Modbus TCP IP device. Then after, it will publish your Modbus data to MQTT broker, and then after, you can use any MQTT client software to connect with MQTT broker and to read those data. Okay, so this is the basic data flow diagram which we are going to use in this video. Now once you download the code, you will have 4 files inside the project folder. Okay, the main file is the index.js file, and index.js file will work based on the config.json file. So whatever configuration you do in the config.json file, index.js will work upon that. Okay, so those things we are going to see in the future. So first of all, you have to install the necessary packages and library to run the index.js file. So all you have to do is run the command prompt in the same location and run the command npm install to install the necessary library in your system. Okay, you can see added 64 packages. So all packages are installed in your folder. Now we can run the index.js file. But before that, we have to provide our configuration in the config.json file so that index.js won't give us any error. Okay, so let me open the config.json file. Also, let me open our OpenModSim software, which is used to simulate our Modbus TCP device. Okay, and you can use this OpenModSim software free of cost without paying any charges because this is the open source and free software. Okay, and the alternative of Modbus Slave software, or you can say Modbus Sim software. Now in the config.json file, you have to provide few details. So first of all, you have to provide the IP address of your Modbus TCP device which we are going to connect with. And then after, you have to provide the port number, okay, of your Modbus TCP device. So right now you can see I have provided localhost IP address because I have run this simulator in my local system. So that's why I have provided the localhost IP address. And then after, the simulator is running on port number 502, as you can see here. So that's why I have provided port 502. Now the slave ID. So here you can see slave ID is 1. Okay, that's why I have provided slave ID 1. Then after, interval. So interval is the reading interval. So at what interval it will read the data from your Modbus TCP device and it will publish to MQTT broker. So that interval we have set to 1000 millisecond. Okay, so it will read the data at every second and it will publish the data to MQTT broker at every second. Then after, this is the register section. So I'll come to this later. Before that, this is the MQTT section. Okay, so in the MQTT section, you have to provide the broker IP address or the host name, broker port number, okay, username and password if any, to connect with your MQTT broker. And this is the base topic in which we are going to publish the data. Okay, so that's it about this MQTT broker details, and here is the Modbus device detail. Now the main part is this, to define the register, that which register we are going to read and for which register we are going to publish the data to MQTT broker. So we have 4 types of registers, right? Holding register, input register, coil, and the diskette input. So you can create this kind of section for each of them and you can configure it to read it and to publish the data to MQTT broker. I have used input and holding as of now, but you can extend this for coils and discrete inputs. Now the first section we want to read is the holding register. Starting address is 0. Okay, so this 40,001 is corresponding to starting address 0 and ending address is 2. So this is the 0, this is the 1, and this is the 2. Okay, so it will read holding register 0, holding register 1, and holding register 2, and then after it will publish the data to MQTT broker. And the second set we want to read is again holding register, but with the starting address of 5. Okay, so this is the starting address 5, and we want to read total 3 address. Okay, 5, 6, 7. So it will read 40,006, 40,007, and 40,008, and it will publish the data to MQTT broker. And then after we want to read the input register starting from 0, and total quantity we want to read is 3. So 0, 1, 2, ending address is 2. Okay, so that's why 3 quantity. So 30,001, 30,002, and 30,003. So this 3 quantity we want to read and we want to publish it to MQTT broker. Okay, now this starting address 0 is always correspond to 40,001 or 30,001. Okay, so you have to make sure of this. And here you have to provide the name of your tag. Okay, right now I have provided input register tag 0, input register tag 1, input register tag 2, but whatever device you are reading the data, okay, based on the device you can provide the tag name here, like it's your voltage, it's your frequency, it's your power. Okay, whatever it is, you have to provide those details here, or you have to provide the tag name here, so it will be populated in your MQTT broker. Okay, now everything is set up. We can save this config.json and we can run the index.js file to publish our Modbus device data to MQTT broker. Now to run the index.js file, all you have to do is you have to type node index.js. Okay, so first it will connect to Modbus device. You can see connected to Modbus device, and then it will connect to MQTT broker. Okay, so it is successfully connected to both of the system. Now it is publishing the data, and if you want to see the data, then we have to open any MQTT client software. So I'm going to use the MQTT Explorer software. Okay, and we will connect to HiveMQ broker, and then I'm going to connect. Okay, now you can see we have the base topic here, which is Modbus/data. Okay, so main topic is the Modbus. Inside that we have a data topic, and inside that we have a 4 topic: holding register, input register, discrete input status, and the coil status. Now in the holding register, you can see holding register 0 is correspond to this one. Okay, 79, 96. Okay, and holding register tag 1 is this one, holding register tag 2 is this one. Okay, so this is how you can monitor your Modbus TCP device data from anywhere in the world using this JavaScript code. Okay, so you have to run this code in your Raspberry Pi. It will connect to your Modbus TCP device and it will continuously publish your data to MQTT broker. It can be your local MQTT broker or it can be your cloud MQTT broker. Okay, and then after you can integrate this data to any system, and also you will get the timestamp. You can see at every second we will have a data. Okay, 50, 18, 19, 20. Okay, here also you can monitor your timestamp. So this is how you can use JavaScript to create your own unidirectional Modbus to MQTT converter, or you can say Modbus to MQTT publisher. Also here you can read the input register data. Okay, you can see the first 3 input register data is available here. Okay, if you want to change the config.json, then you can change the config.json to add few more input register. Okay, so if you want to add, then you can copy this one, you can add it here. Okay, and you can add like this. Okay, once you do the change, you have to save the config.json file, and then you have to cancel this, and then you have to again run the index.js file. Okay, that's it. Now here you can see we have input register 0, 1, 2 and 5, 6, 7. So 5, 6, 7 correspond to 6, 7 and 8. If I change the input register 5, like if I change the value to 55 here, okay, then it will be available here. You can see 55 is available here. If I change the value to 99, then it should available at the same location. Okay, so this is how you can use this JavaScript code to publish your Modbus TCP device data to MQTT broker at interval of 1 second. Okay, so I hope everything is clear, and if you want to download the code, then you can click here and you can download the code, and you can follow this video to set up your unidirectional Modbus to MQTT publisher in the JavaScript. Okay, so if you have any questions or any doubt, then you can always ping me on Telegram, Instagram, WhatsApp, anywhere. Also, you can comment on this video. Also, you can send me a mail. Now we will meet you in the next video, and in the next video maybe we are going to cover the same thing for our Modbus serial devices. Okay, so this is for Modbus TCP device, so it will read the data from TCP device and it will publish to MQTT broker. Now we can also use the same code by little modification for Modbus serial devices. So let's cover that in the future videos. Till then, take care, goodbye, and thank you.